So, from the topic of wave motion, there is a possibility of getting 2 to 3 questions from wave motion. In any objective point, it has a more weightage, more important chapter it is. In the topic of wave motion, we have to discuss mainly about these areas. One is about the classification of waves, next one is characteristics of wave, displacement relation of the progressive wave. So, this is one of the area of asking questions. And next topic is speed of travelling wave, speed of sound. This is one area of asking questions. And one more is reflection of waves, principle of superposition of waves, standing waves. This is one area of asking questions. One more is about the organ pipes. And one more topic is about the beats and Doppler's effect, and finally characteristics of musical sound, in that loudness, pitch, quality and intensity of sound. Out of these 4 areas, majority of the questions may be asking from intensity of sound. So, this is how various branches of the wave motion. Let us discuss about the classification of waves and the properties of waves. There are 2 ways of transporting energy from one place to the another place. One method is without the transport of matter, and second method is with actual transport of matter. For example, in order to transport the energy from one place to another place with the actual transport of matter, let us see one example. When a bullet is fired from a gun, bullet carries energy, kinetic energy. It transfers from one point to another point and transport energy. This is what we call process of transport of energy with actual transfer of matter. And one more example, the transport of energy without actual transport of matter, that is propagation of sound. The sound is propagating from one point to another point without the actual transport of matter. For example, between you and me, some media is transferring energy, sound energy from my, that is the source of sound, to the listener. For example, between you and me, media is there. This media transferring energy from one point to another point. If this complete matter transferred to you, after some time you cannot hear my voice. Therefore, the propagation of sound from one point to another point without the actual transport of matter. There are 2 ways of transporting energy from one place to the another place. The first method is the transporting energy without actual transfer of matter. The second method is the transport of energy with the actual transport of matter. In the first method, as I told you earlier, the transport of energy is of 2 methods, with the actual transport of matter, without actual transport of matter. In the first method, let us see one example with actual transport of matter. When a bullet is fired from a gun, bullet carries kinetic energy with it and it is transferred to one point to another point where the amount of energy is utilized by it. That is one method. And second method is without actual transport of matter. For example, the sound, the propagation of sound from one point to another point. During this process, energy carried by a wave without transporting matter. And one more example, let us see. When on the surface of water, suppose there is a cork. When a stone is dropped, that means when a disturbance is created at one point, the disturbance will transfer from one point to another point. That means the cork which is placed over the surface of water will not transfer from one point to another point. In this case, the energy is transferred, disturbance is transferred, momentum is transferred, energy is transferred, but the matter is not transferred from one point to another point. So, this is how the transport of energy can differentiate in 2 methods. Wave. Wave is a disturbance that propagate in space, transport momentum, energy from one point to another point without the actual transfer of matter is what we call a wave. That means when a wave is traveling from one point to another point, here momentum is transferred, energy is transferred, disturbance is transferred, but matter will not transfer from one point to another point. Therefore, wave is nothing but a disturbance that propagates in space from one point to another point without actual transfer of matter is what we call a wave. Example for wave, one is sound, other is light, and like this many examples of waves on a string, etc., etc. Now, depends upon the direction of propagation of energy, the waves are classified into three categories. Those are one dimensional, two dimensional, and three dimensional. One dimensional example is waves on a string, two dimensional are ripples on a liquid surface, three dimensional are sound and light. When a sound is produced from a source of sound, that sound is propagated in all directions. That is the reason why they are called as three-dimensional sound waves. Now, classification of waves. These waves are basically classified into two categories. One is about the mechanical waves and other is about the non-mechanical waves. These mechanical waves require medium for the propagation, whereas non-mechanical waves do not require any medium for the propagation. So, example for mechanical waves are sound waves, the best example for mechanical waves. So, non-mechanical waves are light waves, they do not require any medium for the propagation. Therefore, waves are basically classified into two types. One is called mechanical, other is called non-mechanical. For mechanical waves, medium is required for the propagation. For non-mechanical waves, medium is not necessary for the propagation. Next, based upon the energy propagation, mechanical waves further classified into two categories. Those are progressive waves and other is about the stationary waves. And progressive waves are nothing but when a wave is produced at a point, that wave will propagate further. Never reflection takes place unless obstruction takes place by a wave. Such waves are called as what we call as a progressive waves. Depends upon the direction of wave. These progressive waves further classified into two categories. One is called longitudinal progressive waves, other is called transverse progressive waves. I repeat again, waves are classified into two categories. One is called mechanical, other is called non-mechanical. Basic difference between them is these mechanical waves require medium for the propagation, non-mechanical waves do not require any medium for the propagation. Further, based upon the energy, these mechanical waves further classified into two categories. One is called progressive mechanical waves or simply a progressive waves, and other is what we call stationary waves. And further, depends upon the direction of propagation of wave, these progressive waves are of two categories. One is called longitudinal progressive waves or simply a longitudinal waves, other is what we call transverse progressive waves or simply a transverse mechanical waves or transverse waves. And further, these longitudinal waves, so in case of longitudinal wave, direction of vibration of particles is along the direction of propagation of wave. That means, the wave is propagating like this, the molecules present in a wave are also vibrating along the same direction. So, here we can say the direction of vibration of particles. So, direction of vibration of particles is along the direction of propagation of wave. Such waves are what we call longitudinal mechanical waves, longitudinal progressive waves or simply a longitudinal wave. Example, sound waves are longitudinal. Next, about the transverse waves. In the case of transverse waves, this is direction of vibration of particles, this is direction of wave. That means, if the direction of vibration of particles is perpendicular to the direction of propagation of wave, such waves are what we call transverse mechanical waves or transverse progressive, simply transverse waves. Now, these longitudinal waves can propagate through solids, liquids and gases even, whereas the transverse waves predominantly passes through solids. So, because the cohesive force between the molecules of a gas is very less, that is the reason why transverse waves predominantly passes through solids. In the case of longitudinal, they can pass through solids, liquids as well as gases. So, this is how the waves are classified. equation of progressive wave. These are the various forms of the progressive waves. Y is equivalent to A sin omega t. So, this is how the wave will propagate along the positive x-axis. Y is equivalent to A sin omega t minus kx. This is Y is equal to A sin kx minus omega t plus phi, positive initial phase constant. The curve starts from left of origin. So, here this curve represents Y is equal to A sin kx minus omega t plus phi, the curve starts from right of origin. So, these are the various progressive wave equations. So, these are the various forms of equation of progressive wave. One is Y is equal to A sin omega t, this is how the waveform is, and Y is equal to A sin omega t minus kx. This wave is nothing but moving along the positive x-axis. Y is equal to A sin kx minus omega t plus phi. This curve starts from left of origin, and Y is A sin kx minus omega t minus phi. This curve starts from right of origin. Y is equal to A sin kx minus omega t. This is one of the form of progressive wave, and Y is equal to A cos omega t starts from here. This is one of the form of progressive wave. So, these are the various forms of progressive waves. Now, on the whole, Y is equal to A sin omega t, Y is A sin omega t minus kx, or Y is equal to A sin omega t plus kx, Y is equal to A sin kx minus omega t, Y is A sin kx minus omega t minus phi plus or minus phi, A cos omega t, A cos omega t minus kx, A cos omega t, kx minus omega. These are the various forms of equation of progressive wave. So, this is one of the most important area of asking problem. So, here the condition for the waveform or the wave function is, the wave function should be finite and single valued, and it must be continuous, that is nothing but it should be differentiable. And third condition, the shape of the wave must be constant throughout the motion. That means, as long as the wave is propagating through a homogeneous medium, the shape of the wave does not change. So, these are the three conditions has to satisfied by the equation of progressive wave. Those are the three conditions. For example, based upon this, Y is equivalent to A sin omega t plus or minus kx, or Y is equal to A into e power minus of ax plus bt square, or A by b plus x minus vt square, or Y is equals to under root of x minus vt, or Y is equals to A into e power minus b of x minus vt whole square. These are the different forms of equation of progressive wave which satisfy all these three conditions. I repeat again, the wave function should be finite and single valued. Second condition, it must be continuous, that means it must be differentiable. Shape of the wave must be constant. What do you mean by that? As long as the wave is propagating the homogeneous medium, the shape of the wave does not change, should not change. If these three conditions are satisfied by a progressive wave, then those various forms of equation of progressive waves are these I shown you earlier over here. Now, here some examples of the Y is equal to x square minus v square t square, or root x minus root vt of sin of x square minus bt square. These are the forms of equations which do not satisfy these conditions. Therefore, the equations which are in the form of this are not form of the progressive wave. That means which do not represent a progressive wave. Y is equivalent to A sin omega t minus kx is the representation of a progressive wave moving along the positive x-axis. Y is equivalent to A sin omega t plus kx is the wave which is moving along the negative x-axis. Y is equivalent to f of vt minus x. This is the form of progressive wave equation or progressive wave which moves along the positive x direction. y is equivalent to f of Vt plus x. This is the form of progressive wave which moves along the negative x direction. So, here the travelling wave or a progressive wave, both are equal, both are same over here. Travelling wave is a sine or cosine function of At minus Bx or At plus Bx. So, this is the final form of the progressive wave. The progressive wave is of the form of y is equivalent to f of Vt minus x. If it is in the form of this, the wave is said to be moving along the positive x axis. If it is in the form of f of y is equals to f of Vt plus x, this is the representation of a progressive wave which is moving along the negative x direction. So, therefore, the function can be either sine or cos. The travelling wave is a sine or cosine function of At minus Bx or At plus Bx. On the whole, you can remember one thing, that if it is in the form of f of Vt minus x moving along the positive x direction, if it is in the form of Vt plus x moving along the negative x direction. So far we discussed about the various forms of the progressive waves. So, finally, you remember only one thing, that y equal to a sin omega t plus or minus kx, or y is equal to a cos omega t plus or minus kx is the equation of progressive wave. If the wave equation is given like this, the various forms of the progressive wave, a sin 2 pi omega is equivalent to, we have 2 pi f, omega is what we call angular frequency, f is called frequency. So, omega value can be replaced by 2 pi f. By replacing omega is equivalent to 2 pi f, a is a sin 2 pi ft minus x by lambda, where k is called propagation constant. I repeat again, in this equation, omega is the angular frequency, omega is equivalent to 2 pi f, where k is called propagation constant, which is k is equivalent to 2 pi by lambda. By replacing omega and k as these values in this equation, you will be getting a sin 2 pi of ft minus x by lambda. And further, a sin 2 pi, f is the frequency, this capital T is what we call time period. Time period t is the inverse of the frequency. Therefore, frequency can be replaced by 1 by t. This is as it is. So, this can be modified as a sin omega t minus plus kx can be modified as a sin 2 pi of ft minus x by lambda, can also be modified as a sin 2 pi small t by capital T minus x by lambda. And further, this equation can also be written as a sin 2 pi by lambda into Vt minus x, where V is the velocity of wave. So, therefore, these are the various forms of a progressive wave. Let us see what are the various letters indicates. Here in this equation, y is equal to a sin omega t plus or minus kx, where y represents displacement of particle, a represents amplitude. We will discuss about the amplitude in the further topic, where f is the frequency, omega is called angular frequency, x is called displacement of wave, where v is the velocity of wave, where k is called propagation constant. We will discuss about all these properties of the waves in further topic. So, finally, you remember only one thing about the equation of progressive wave. If any problem comes under the concept of equation of progressive wave, we have to compare that given equation with general wave equation of progressive wave as y is equivalent to a sin omega t plus or minus kx with various forms. So far, we have come across the equation of progressive waves of waveform. Let us see the properties or the characteristics of a wave. That means, one of the property is amplitude. What do you mean by amplitude? Suppose say this is the waveform. These are the particles over the equation over the progressive wave. See, this is the displacement of the particle P from the equilibrium position. So, this is called displacement amplitude. Similarly, one more particle, this is equal to q, the displacement of this particle from equilibrium is y2. One more particle, suppose this is particle is equivalent to r, displacement is equivalent to y3, and one more particle S is equivalent to displacement is y4. That means y1, y2, y3, y4 are the displacement amplitudes, whereas this is the particle, say this is some x, this particle x has the maximum displacement of this particle from equilibrium, that is called as amplitude. So, amplitude means the maximum displacement of vibrating particle from mean or equilibrium position is what we call amplitude. I repeat again, these, for example, particle P, particle Q, particle R, particle S, they have displacements from mean as y1, y2, y3, y4. These are not amplitudes, these are the displacement amplitudes. Whereas for a particle X which is having maximum displacement from mean or equilibrium, so therefore the maximum displacement of the vibrating particle from mean or equilibrium position is called as amplitude. This displaced amplitude is vector quantity. Now let us see the concept of phase. What do you mean by phase? Phase is nothing but the state of vibrating particle at any instant of time is what we call phase. For example, we have equation of progressive wave as y of x comma t is equivalent to a sin kx minus omega t plus phi. Here kx minus omega t plus phi is nothing but a phase of a wave. In this phase, suppose a t is equal to 0, means in the beginning, x is equal to 0, displacement is equal to 0 in the beginning. At t is equal to 0, x is equal to 0, the phase phi is called initial phase. So, simply to remember phase as angle, nothing but an angle. Next, about the concept of wavelength. See, this is one wave, these are the two particles P and Q whose displacement amplitudes are y1 and y2. Wherever you want to find out the direction of propagation of wave, simply there you draw a tangent. Direction of tangent at P, direction of tangent at Q gives direction of wave propagation. Suppose the particle P and particle Q have displacements as y1 and y2. If y1 is equivalent to y2 and the particle P, that means particle P and particle Q have equal displacements. Now, directions of the particles at P and Q are same. That is, direction of propagation of wave at P and Q are same direction. Displacements the particle P and Q having y1, y2 which are equal. We can say the two particles P and Q are said to be in same phase. So, here wavelength is nothing but the minimum distance between two points having same phase. There is only one point successive to P which is having same phase is Q. So, the distance from P to Q is nothing but a wavelength lambda. Or in a transverse wave, these are the 2 points. This is what you call crest, this is called crest. This is a trough, this is a trough. So, here crest and crest, these two particles are in same phase. Trough and trough, these two particles also in same phase. The point P, point Q are also in same phase. Therefore, the minimum distance between 2 points having same phase is what we call wavelength. Therefore, we can define wavelength as the distance between two successive particles which are in same phase, or in transverse waves the distance between two successive crests or two successive troughs. In case of longitudinal progressive waves, the distance between two successive compressions or two successive rarefactions is also called as wavelength lambda. So, wavelength can be defined as the minimum distance between 2 points having same phase, that means which are in same phase. Otherwise, it is the distance after which the wave repeats itself. That means, suppose the wave starts from here, imagine it completes one wave till Q. So, the second wave is repeating after crossing the point Q. So, we can say it is the distance after which the wave repeat itself is also called as wavelength. And one more is distance travelled by wave in one vibration. In one vibration is also called as wavelength. So, finally, we can say one thing, the distance between two successive particles which are in same phase is called as wavelength. That may be crest to crest, trough to trough, compression to compression, or rarefaction to rarefaction. That is about the concept of wavelength. One more property of progressive wave is angular wave number or propagation constant. Yx comma t, a sin kx minus omega t plus phi. This is the equation of progressive wave. If phi is equal to 0, then what happens? If when phi is equal to 0, initially at t is equal to 0 time, yx comma 0 is equivalent to a sin kx. That is nothing but a t is equal to 0 means in the beginning. Phi is equal to 0, initial phase is equal to 0. In that case, the equation of progressive wave will become y is equivalent to a sin kx. This a sin kx can also be written as a sin kx plus 2n pi, because in the case of sine function, sine of 2 pi plus theta is equivalent to sin theta itself. That means a sin kx can also be written as a sin k of x plus 2n pi by k. Now, at points x and x plus 2n pi by k, the displacements are equal. That means at t is equal to 0 in the beginning, the displacement is equal to x, and after some time, that is equivalent to after time of time period t, the displacement is a sin k into x plus 2n pi by k. In this case, at points x comma x plus 2n pi by k, displacements are equal. Now, the least distance between these 2 points, that's what you want to calculate to find out the wavelength, that is what you call lambda. So, if n is equal to 1, this will become x plus 2 pi by k. Initial first point is x, next successive point is x plus 2 pi by k. So, the least distance between these 2 successive points is x plus 2 pi by k minus x, which is equivalent to 2 pi by k. Therefore, from this one, wavelength lambda is equivalent to 2 pi by k, or k is equivalent to 2 pi by lambda, where k is called as the propagation constant. This is how the propagation constant k and the wavelength lambda are related. Now, mainly this k value k is called propagation constant. This k depends on nature of source emitting waves, and k also depends upon the nature of medium. This is how wavelength and the propagation constant are related to each other. Next, one more property of the wave is nothing but a time period. Time period is a time after which the wave repeat itself. That is, the time taken by a wave for the completion of one wave is also called as time period. Suppose in this wave, the time of the particle p from the initial point is t seconds. After t dash seconds, let the particle is at point q. Now, the difference of t dash and t is equivalent to time period t, which is equivalent to 2 pi by omega. Let us see mathematically how can we solve the equation for the time period. Y of x comma t, a sin kx minus omega t plus phi. So, here when x is equal to 0, when phi is equivalent to 0, this will equation become e minus a sin omega t. This can also be replaced by minus a sin of omega into small t plus capital T, where capital T is the time period. So, this can be simplified as minus a sin omega t plus omega into capital T. So, minus a sin omega t plus omega t can be replaced by 2 pi, which is also equivalent to minus a sin omega t. That means, reason is that the sine function repeats after every 2 pi radians. That is nothing but a sine of 2 pi plus theta is nothing but a sine theta. Therefore, this omega into capital T is equivalent to 2 pi. From this one t is equivalent to 2 pi by omega. On the whole, no need to remember all these concepts. You remember only one thing, that time period t is equivalent to 2 pi by omega. Now, one more property is wave velocity or phase velocity. We have omega t minus kx is for phase. The phase is equals to constant. Just now I explained you earlier concept. As long as the wave is propagating through a homogeneous medium, omega t minus kx value is a constant. That means omega t is equivalent to kx. So, omega t minus kx is equals to constant. If you differentiate this, omega dt is equivalent to k into dx. From this one, dx by dt is equivalent to omega by k. Omega by k is nothing but omega can be replaced by 2 pi f, and k is equivalent to 2 pi by lambda. From the earlier discussion, we come across omega is equivalent to 2 pi f, propagation constant k is equal to 2 pi by lambda. From this one, 2 pi gets cancelled over here, which is equivalent to v. Otherwise, f into lambda, which is equivalent to v. I repeat again, omega t minus kx is the phase of a wave which is constant. As long as the wave is propagating through a homogeneous medium, the phase is constant. Therefore, omega t minus kx is equals to constant, omega t is equals to kx. By differentiating on both the sides, we got dx by dt is equivalent to omega by k. We know that omega is called angular frequency, which can be written as 2 pi f, where k is called propagation constant, that can be written as 2 pi by lambda. From the simplification, this can be replaced with v. Therefore, dx by dt nothing but omega by k, nothing but v. Therefore, wave velocity v is equivalent to omega by k is equivalent to f lambda. Let us see the relation between path and phase and time. So, let us consider the position of two particles at displacements of x1 and x2. For first particle, phase phi1 is equivalent to omega t minus kx1. For the second particle, phi2 is equal to omega t minus kx2. Now, we would like to find out the phase difference. Phase difference between these two particles is delta phi is equivalent to phi2 minus phi1, which is equivalent to, from this subtracting one from the other, we will be getting 2 pi by lambda into delta x. This is the phase and path relation. That is, delta phi is equivalent to 2 pi by lambda into delta x. This is nothing but a phase. This is called phase, this is called path. Phase difference is equal to 2 pi by lambda times of path difference, or path difference delta x is equivalent to lambda by 2 pi times of phase. So, this is between path and phase relation. Now, phase and time relation. So, here after the two particles after time intervals of t1, t2, let the phases are phi1 is equivalent to omega t1 plus minus kx, and for a second particle phase is omega t2 minus kx. The phase difference between these two particles in a time gap of t2 minus t1 is delta phi is equivalent to 2 pi f of delta t. That is nothing but a phi1 minus phi2 or phi2 minus phi1. These two gets cancelled. Here omega of t2 minus t1, omega of t2 minus t1, which is nothing but a 2 pi f. Here I wrote here clearly, delta phi is equivalent to omega of t2 minus t1, which is equivalent to omega can replace by 2 pi f. The difference of time is delta t. Therefore, delta phi is equivalent to 2 pi f into delta t, or 2 pi by capital T into delta t, where capital T is what we call time period. Now, path phase relation is delta phi is 2 pi by lambda into delta x. Phase path relation is delta x is lambda by 2 pi into delta phi. Now, phase time relation is delta phi is equal to 2 pi by capital T into delta t. Now, how all the three are interlinked with each other? Delta phi is equivalent to 2 pi by lambda into delta x, which is also equivalent to 2 pi by capital T into delta t. That means easiest way of remembering this relation is, see, this is one wave, So these are the two particles, one particle is P, one more particle is Q. This is the distance from P to Q is what we call wavelength lambda. The phase difference between the two particles of P and Q is delta phi is equivalent to 2 pi radians. The distance between two particles P and Q, delta x is equivalent to lambda, and the time interval between P and Q, delta t is equivalent to t. That means lambda corresponds to 2 pi corresponds to t. This is the path, phase and time relation. That means suppose you want to calculate, you want to convert lambda by 2 path in terms of phase, For that what to do? Simply in place of lambda, replace lambda with 2 pi, that is 2 pi by 2 is equivalent to pi radians. When path is given, to convert into phase, this is the method. For example, phase is given as, suppose when phase is equals to given as pi by 2, how to convert this in terms of path? So pi by 2 can be replaced by simply in place of pi is equivalent to lambda by 2 which is equivalent to lambda by 4. Or suppose you have pi by 3 is given, 2 pi by 3 is given, simply 2 into in place of pi lambda by 2 by 3 is equivalent to lambda by 3. Suppose the time interval between any 2 points over the wave is t by 4. How to convert this in terms of phase? T by 4. In place of t, this can be replaced by lambda by 4. In terms of phase, this t can be replaced by 2 pi by 4 is equivalent to pi by 2. Therefore, this is the easiest way of converting path in terms of phase, phase in terms of time, etc., etc. By remembering only one relation, that is lambda corresponding to 2 pi corresponding to t. Lambda is the path, 2 pi is the phase, t is the time. Now let us see the relation between particle velocity and wave velocity. Particle velocity and wave velocity. We have equation of progressive wave as y is equivalent to a sin omega t minus kx. If you differentiate this with respect to time, dy by dt which is equivalent to a sin d by dx of sin is cos. So again we should differentiate with respect to this as t, so which is equivalent to omega. Therefore a omega cos of omega t minus kx. I repeat again, wave velocity, we know the displacement of the wave, is y is equivalent to a sin omega t minus kx. If you differentiate the displacement with respect to time, dy by dt is equivalent to a as it is, d by dx of sin is equivalent to cos, therefore cos of something. Again we should different interior function with respect to t, you will be getting omega, on the whole a omega cos of omega t minus kx. This is also equivalent to a omega cos something can be replaced by 1 minus sin square omega t minus kx, a omega under root of 1 minus sin square. We know that sin omega t minus kx is y by a. So replace this function, this value by y by a, 1 minus y square by a square, which is equivalent to a omega under root of a square minus y square by a square. Square root of a square is equivalent to a gets cancelled. After simplification of this, we will be getting omega under root of a square minus y square. Therefore, where y is the displacement of particle, where v is the velocity of the particle. Therefore, velocity of particle Vp is equivalent to omega under root of a square minus y square. This whole value to be maximum. This maximum value is possible when y is equal to 0. Y is equal to 0 means equilibrium or mean position. That means when y is equal to 0, that is at mean or equilibrium position, Vp which is equivalent to a square minus 0 square which is root of a square is equivalent to a is equivalent to plus or minus a omega. Therefore, particle velocity at mean position is a omega, which is nothing but a maximum value. Therefore, maximum particle velocity is plus or minus a omega. That means at the mean position, the particle, if it is moving towards right, which is having a V maximum value as plus a omega, if the particle moving from mean or equilibrium position towards left extreme or towards left, we can say V maxima is equivalent to minus a omega, and therefore V maxima is equivalent to plus or minus a omega. That is what we call particle velocity at mean position. Now, this whole value to be maximum, we want to find the minimum value. To find out the minimum value over here, if you replace y with a, that means if y is equivalent to plus or minus a, velocity of particle value becomes 0. That means y is equivalent to plus or minus a. This is possible at extreme points, where the extreme points velocity of particle is equal to 0. So, from this explanation we can say that wherever you want to find the velocity of particle, use the formula V is equivalent to omega root of a square minus y square, and from this expression we can find out the maximum value, minimum value. Those maxima, minima values are maximum value plus or minus a omega, minimum value 0. So, this is the concept of velocity of the particle or wave velocity. Yeah, now let us see relation between the particle and the wave velocity. As I explained you earlier, the displacement of particle is y is equivalent to a sin omega t minus kx. If you differentiate this with respect to time, you will be getting velocity of the particle. Where y is the displacement of particle, if you differentiate this with respect to time, you will be getting velocity of the particle. Velocity of particle is equivalent to dy by dt is equivalent to a omega cos of omega t minus kx. If you differentiate this with respect to x to find out the slope, therefore slope of wave can be obtained by differentiating this equation with respect to x. So, dy by dx is equivalent to a sin, instead of sin it is cos omega t minus kx. If you differentiate the interior function with respect to x, you will be getting minus ak cos omega t minus kx. So, equation 1 represents velocity of particle, equation 2 represents slope of wave. From equation 1 and 2, I repeat again, check once again clearly, velocity of particle is a omega cos of omega t minus kx. Slope of wave is minus ak cos omega t minus kx. If you divide 1 with 2, you will be getting Vp by slope. Vp means velocity of particle, slope is equivalent to minus omega by k. As we discussed earlier, omega by k is nothing but a velocity of wave. Therefore, Vp is equivalent to negative slope of velocity of wave. So, this is the relation between particle velocity and the wave velocity. Let us see one example how they will be asking in the exam, how this concept is useful for us. See, if the slope is negative, negative of negative will become positive, velocity of particle is positive. If the slope is, I repeat again, slope is negative, this whole value become positive, velocity of particle is positive, direction is upward. If the slope is positive, minus of positive slope, this whole value become negative, velocity of particle is negative, direction is downward. So, see, let us see this example. This is one wave. In this wave, the various particles are A, B, C, D, F, G, H, etc., etc. Now, we want to know direction of propagation of particles. For a particle B and for a particle H, they have positive slopes. Slope is positive, velocity is negative. Therefore, direction of motion of the particles B and H is, as it is negative, downward. For a particle D, for a particle E, for a particle F, they have negative slope. As the slope is negative, minus of negative value will become positive, direction is upward. Now for a particle C and for a particle G, so here slope of this particle is C is 0, slope of particle G is equal to 0, slope is equal to 0, velocity is equivalent to 0. So here for a particle A and for particle E, the slope is maximum. So for a maximum value, velocity of particle is maximum. So we can say for a particle A, E, they have maximum velocity. For a particle C and G, velocity is 0. For a particle B, velocity is minus of positive slope is negative, direction is downward. For a particle F, slope is negative, Vp value positive, direction is upward. So here for a particle B, direction is downward. For a particle F, direction is upward. And for a particle G, velocity is 0. For a particle C, velocity is 0. For a particle A and for a particle E, velocity is maximum. A longitudinal progressive wave is represented by y is equivalent to 5 into 10 power minus 2 sin pi of 400t plus x of meters. So he may ask us to calculate amplitude, frequency, wavelength, velocity, and like this various values he may ask us to calculate. So in this problem, whatever the values you want to calculate, that you think about the later. First you compare the given equation with the general wave equation of y is equal to a sin omega t plus r minus phi. In this comparison, directly we can say in place of a we have 5 into 10 power minus 2. So amplitude is a is equal to 5 into 10 power minus 2 meters. In place of omega we have 400 pi. Omega is equal to 2 pi f, which is equivalent to 400 pi. On simplification, f is equivalent to 200 hertz. The velocity of wave v is equal to omega by k. Omega value from the comparison we got 400 pi and k is equivalent to pi because k is equal to pi. On substituting simplification we got this value. Velocity of particle we know the formula minus a omega cos omega t plus kx. On simplification of these values we will get 10 root 3 pi meter per second square. Similarly, acceleration of particle is minus a omega square sin of something. After substitution values we will be getting this. Similarly, only one thing we have to do, the given equation must be compared with the general wave equation, and using the simple formula we can find out the various values. Let us see one more most important problem. Two waves of wavelengths lambda 1 value 1.6 meters and lambda 2 1.7 meters travel out from common point. Initially they are in same phase. The minimum time after which they will be again in same phase. That means he is asking us to find out the time gap or the time difference between the, again they will be in same phase. For example, we know the relation between them, delta phi phase is equivalent to 2 pi n1 minus n2 delta f or frequency difference into delta t. This relation between the path and the time relation. The minimum phase, again the two particles in same phase is 2 pi radians. This one is very important. That is the minimum phase between the two particles, again they will be in same phase is 2 pi radians. Using this value, using this formula, delta phi is equivalent to 2 pi as it is. This value difference of frequency n1 minus n2, that can be replaced by n is equivalent to v by lambda. So n1 can replace by v by lambda 1, n2 can replace by v by lambda 2 into delta t. So here 2 pi gets cancelled. Simplification of this delta t is equivalent to lambda 1 lambda 2 by lambda 2 minus lambda 1 whole by v. He gave the v value as 340 meters per second. Lambda 1, lambda 2 values are 1.6 and 1.7. Substituting these values after simplification of this, you will be getting 0.08 seconds. That means after 0.08 seconds, again the two particles are in same phase.